This meeting is being recorded.
Let's take a look now at sample exercise number 19. This will be the last practice problem that we solved together from this chapter. And it is, again, an example that reviews the selective precipitation of ions. So we're given here a solution that contains both 0.05 molar concentrations of magnesium 2 plus and copper 2 plus ions. So the same starting concentrations of each. And we're asked to determine which ion will precipitate first as OH is added. So this should actually be which salt, right, will precipitate when we have our magnesium ion mixed with hydroxide or copper. So the concentration of hydroxide is, in the second part, we're asked what concentration of hydroxide is needed to begin each precipitation. So technically, we're going to have to solve the second part first, solve for hydroxide, and then we can determine which would precipitate first. So we'll do this in 3 steps. So step 1, we'll write out our reaction. So we see our ionization of our magnesium. Step 2, find our KSP expression. So this is going to be the concentration of magnesium 2 plus times the concentration of hydroxide squared. Notice that in both of these equations, we're going to have 2 hydroxide ions in the dissociation. So we're going to have both equations will have that exponent squared. So we'll set our KSP equal to our concentration of magnesium, so 0.05 times hydroxide squared. If I was to divide by 0.05 on this side and then take the square root, that would give me that I need 1.9 times 10 to the negative 5th molar concentration of hydroxide needed to start the precipitation of our magnesium hydroxide. Then we'll take a look down here. Now that we've solved for hydroxide in part 3, we'll take a look at writing our copper hydroxide ionization equation first. Then in part 2, we have our, in step 2, we have our KSP expression given, so copper 2 plus times hydroxide squared. Then we're going to set our KSP value equal to our concentration of our copper 2 ions, and then times hydroxide squared. So again, I'm going to divide here by 0.05 and then take the square root. So in this case, I only need 9.8 to the negative 10th molar. So my copper hydroxide, we would say, would precipitate out first. That salt would form first. The ion would precipitate first, however you want to phrase that. Because we have a much lower concentration needed for our hydroxide ions, and compared to the negative 5, we know that negative 10 is a much smaller number.